Uh, okay, so hello everyone. Myself Kunal, and I'm your mathematics tutor. And we are actually covering definite integration. And today is our lecture number 2. And today we are gonna learn some new property and mostly the Wallis formula. Today is our lecture 2 of definite integration. So let's start the lecture. So in last class, we read that if, let me recall you, if integration of fx dx from a to b is 0, then there lies a value, then there lie a c which belongs to a between a and b such that fc is equal to 0, right? There, there lies at least one c, right? So we first take example on this and try to show how is it possible or not. Okay. So our first example based on the previous last things that I taught you, which is any if any integration from A to B is 0, that means the area is 0 between A to B, then the function has at least one root, and that root lies between the upper limit and the lower limit. So let me write the question. If 2a plus 3b plus 6c is equal to 0, then prove that fx is equal to ax square plus bx plus c must have a root in 0 to 1, right? We have to prove that if 2a plus 3b plus 6 is equal to 0, then fx is given, which is ax square plus bx plus c, must have a root in 0 to 1. That means if we go through the proof, that means its integration should be 0 between 0 to 1, right? Because if it has a root between 0 and 1, and we know that if integration is 0 between a and b, then there must lies a c between a and b where fc is 0. That means root exists. So let us integrate this function and try to check is it possible or not. So if we integrate this function, what we get? A by 3 x cube plus b by 2 x square plus cx, right? And we have to put a value from 0 to 1. So let's substitute first the upper limit. So what we get? We get a by 3 plus b by 2 plus c. And when we're substituting the lower limit, which will be 0, we have to subtract it. So it will be minus of 0. So what we get? 6a, uh, 2a plus 3b plus 6c by c, right? And we know that this value given is 0. So 0 by 6 is equal to 0. So here from 0 to 1, ax square plus bx plus c is 0, hence proved, right? We shown that the area between 0 and 1 is 0. That means there must lies a root. There must lie a value of x for which function would be 0, right? So it is proven. So this is the way to prove it. Now let's move on to the next thing. If if fx is positive or negative in a to b, then this has to be noted. Then integration of fx dx from a to b is positive, and when fx is negative, so integration of fx dx from a to b is, this has to be noted. If function is positive, its area, if function is positive in a to b, then its area is also positive, and if function is negative, its area is negative. Let me prove it or show you by graph, right? What this statement tells and what it's mean actually. So let us suppose our function is positive. That means this is x-axis, this is y-axis. If our function is positive, that means it lies above the x-axis, right? Let us suppose this for every single x, right? This is a and this is b, right? So for every single value of x, our value of function is positive. This function is positive, so the area is also positive fx dx because it lies above the x-axis. So it's positive. So it's positive. Now the second thing is, this is x-axis and this is y-axis. If our function is negative, there is a, there is b. If you look the graph of the function, this is the graph of the function fx. This is the graph of the function fx. If you look the graph for each and every single value of x, the value of function is negative. This is minus y, right? The value of function is negative. So the fx dx is, so the area and it lies below the x-axis, so area will be negative. I hope it's clear to all of you. Let's move to the second noted point, which is fx dx from a to b is less than or equal to mod of fx dx from a to b, mod of fx dx from a to b. What it saying? This is saying like, I hope you'll all understand what is saying. A to b, we integrating the function fx and then we put the mod. So this mod value will be greater than this. And when we integrate the mod of the function, so it will be the largest. So let me show you again this by graph. So let us suppose this is our function graph. This is x, this is a y-axis, and our function something is uh, like that. So this is our fx graph. Okay. So when we calculate the integration of fx dx part from, like, let me suppose there is a and some there is b. Okay. So when we calculating these area, like this part is a1, this part has area a1, a2, and a3. So from a to b, its value will be a1 minus a2 plus a3, right? This is equation 1. Now when we put the mod on integration, so what I'm trying to say is, let me clear it. If this value comes negative, let us suppose this value comes negative. This, when we solve that, we get minus of 10. So we just put the 10, right? So it is greater than this. And now the third case is mod of fx. The graph of mod of fx look like whatever value is in negative side, just take it to the positive side. So this is the graph of the mod of fx. This is the graph of the mod of fx. So now there is our a and there is our b. So when we take the area between graph and the x-axis, this area is again a1, this area is a2, and this area is a3. So here the area of the mod of fx dx from a to b is counted as a1 plus a2 plus a3. So automatically equation 2 is greater than equal to equation 1, and the following things like equation 2. So that's the same thing is written here. I hope you'll all understand with the help of graph. Now, let's move on to the next thing, which is now there is a question: what equality hold when above or below the function? So that will be taken as that will be taken as a case. Now move to the question, which is look like integrate from -1 to 1 x square d ln x. So what we have to do here, we have to Just write, look, this is the value of ln x because we are integrating the function. This is our integrating function. This is our given integral. We are integrating x square, but with respect to whom? Our elementary element is d of ln x. So that means this is the value of ln x given. Let me write here, if we integrating like a to b from fx dx, if we integrating this function. So this is the value of x given because our elementary element is dx. Our small, very, very small element is given dx, right? These are dx. But if we wrote here ln x, so we are integrating in term of ln x. So there is the ln x, right? These are the value of ln x. Okay. So what I have to do, we just do here some manipulation dx and dx. So when we differentiate this, what we get? Uh, x square ln x differentiation is 1 by x and there is a dx. Now our elementary element change now. First our elementary element is d of ln x. Now our elementary element is dx. So ln x. So now our limit also changes. So we have to find the x. So x is equal to e to the power minus 1 by using just some exponential concept, basic exponential concept. It will be e to the power minus 1 to e to the power. Now, when we integrate this function, what we get? We have to integrate from e to the power minus 1 to e to the power 1 x dx. It will be like x square by 2. E to the power minus 1, e to the power 1. So when we put here e square minus e to the power minus 2, 1 by 2. This is our final value. I hope you'll all understand this. Now, there's an important situation here. This is actually important. What is it? If gx is inverse of, if gx is inverse of fx, that's imply like g of fx is equal to x, right? And domain of the function is lies between a to b such that fa is equal to c and fb is equal to d. Let me write here by in the form of integration. So then you understand. Then integrating a function from a to b plus c to d gy dy, that's equal to bd minus ac. Like the product of upper script minus product of lower script. So this is the important case. If gx, if let us मेरे को समझाने देते हैं. तो यहाँ पे करना क्या है कि if this and this function are inverse of each other, right? And fa is equal to c. When we put this value, we get the value c, and when we put the b here, we get the value d. Then our value of this integration is product of upper limit minus product of lower limit. So let me prove it. How is this possible? Let's proceed on. Let me write here. Proof. What is given first? We have to integrate the function a to b fx dx plus c to d gy dy. Can we write here 1 into fx dx and put it as u and put it as b and then apply the by parts? Applying by parts here. For this part, actually, when we apply the by part, what we get? Fx dot x from a to b minus, we have to differentiate the f, and when we integrate the x, so we get x dx plus, we can write y is equal to fx because it's the inverse, so we can. So there will be like c, when we substituting that, we get here f inverse of c, f inverse of d, and g of f of x, d f of x. We are just changing the our elementary element. So first there is the written x is equal to y is equal to c. Now there is written is fx is equal to c. So the x value is F inverse of 0. So when we substitute here, we get FB dot B minus FA. We are just substituting the limit minus A to B F dash of X dot X dx plus, and we know that the value like F A is equal to C, so F inverse C is A and F inverse B is D, so this and X dot F dash X dx. So this both get cancelled. So at final result, what we get? We get FB dot B minus FA dot A. And we know that FA is equal to C and FB is equal to D. So we get BD minus AC. So this is our proof. Now let's move on to our example. Our example look like 0 to e to the power x dx plus 1 e square ln x dx. So we know that e to the power x and ln x is the inverse function of itself. How we can say that? Like if we take y is equal to e to the power x and take the log both sides, so ln y is equal to x, right? And when we substitute like interchange x to y, so what we get? Ln x is equal to y. This is the way to get the inverse of a function. So these and these functions are inverse of e itself. And when we substitute, like this is our a and this is our b, this is our b and this is our c and this is our d. And when we substituting here e to the power x where x is 0, so we get the c. That means f is equal to c is satisfied and f is equal to d is also satisfied, right? So we can write this integral as directly it will be product of upper limit minus product of lower limit. So it will be 2e square minus 0. So our final answer is 2e square. I hope you'll all understand this. What I'm trying to say is, let's move on to the next example, which is we are integrating the tan inverse of x from 1 to 3. Okay, let me write here. This is our question number 2. We are actually integrating tan inverse of x 1 to 3. So how to integrate this function? We actually know we are doing this by parts. So let's do it by parts. So what we first do, we do like 1, 2, 3, and then we can write 1 into tan inverse of x, and in 1, 2, 3, x to the power 0, tan inverse of x. And then we take, according to the Eilert rule, this is our u and this is our v. So what we do, tan inverse of x. And when we're integrating the x, we get x from 1 to 3 minus, when we differentiate it, I will get 1 plus 1 by 1 plus x square into x. So multiply and divide it by 2 dx. If this is our f function, then this is our df. So what we get, tan inverse of x, x tan inverse x 1 to 3 minus 1 by 2. If this is our f, so this function which is written in numerator is df. Because 1 plus x square is f, so 2x dx is df, right? So what's the integration of 1 by f? df by f. This is ln f. So ln 1 plus x square 1 to 3. Now just insert the limit here and we reach to the final result. So first insert the upper limit. So we get 3 tan inverse of 3, right? And then insert the lower limit. So we get the tan inverse of 1. And we know the tan inverse of 1 is pi by 4, right? So there will be pi by 4 minus 1 by 2. Insert the upper limit first. So we get 1, 3 square 9 plus 1 10. ln 10. And then insert the lower limit, which is ln 1 square 1. So it will be 2. So we get the final result as 3 tan inverse of 3 minus pi by 4 minus 1 by 2. And we just apply the logarithmic property. So we get here ln 5. This is our final answer. Let's move to another example, which is something look like this. We are integrating 0 to 1 e to the power root e to the power x. This is look like complex integrand. Okay, no worry. Plus e to the power root t 2 ln. Let me raise 0. 2 ln of x dx. Okay. So this look like some complex integrand, right? But it is actually easy because one thing you notice here, if we put 0 here, so we get e to the power 0, like let me put here e root under e to the power 0. So we will get e to the power 1. So we automatically get this result, right? And when we put the value 1, so what we get? E to the power 1. So we get e to the power root e, which is actually nothing but the upper limit of the second integral. So what we get from here, we use or learn today a result. Like if a function is inverse of each other and the f is equal to, which is f is equal to c, which we name the c as the second integral lower limit, and f is equal to d, which we named as the second integrand upper limit. So its value will be directly written as bd minus ac. So its integrand value is e to the power root t. And when we multiply it by 0, so it gets 0. This is our final answer. It is as just easy, right? It seems tough, but it's not. It's easy actually. Now, let's move on to the... Actually, one thing you have to notice here, like e to the power root e to the power x and 2 log of log x are inverse of each other, right? So you have to notice it. Now let's move on to the reduction formula, which is quite important here. Like in indefinite integration, we read the reduction formula of integration of tan to the power nx. And here we also read some following thing. So let's proceed. So we are gonna learn here the reduction formula of sine to the power nx and cos to the power nx, and then try to analyze its result, like what we get or how to use it in definite part. So let me write here. Our in is equal to 0 to pi by 2 sine to the power nx dx. And but the noted point is we are just look into the problem which have lower limit 0, LL is 0 and the upper limit pi by 2. So note this thing. Now, sine to the power nx dx is equal to 0 to pi by 2 cos to the power nx dx. So let's try to find it out. What happened? We have to notice here, like this is our in, right? For any n. Let me do something. This is our in. What if our n is 0? And what if our n is equal to 1? So let me write here. If our n is 0, so let's try to find it out. I0 is 0 to pi by 2 sine to the power 0x. So this will be like this will be like dx integration from 0 to pi by 2, right? And when we integrate this, we get the value pi by 2. So I0 is pi by 2. Note this. And when we put the value n is equal to 1, so let's try to put here. In anywhere you can put. So what we get, let's write here 0 to pi by 2. Let's just put in cos nx. This time cos nx. So what we get? Cos x dx. And we know that its integration is sin x. 0 to pi by 2. So we will get the value 1. Right. So I1 is 1. You can also put in sine term if you want. Let me put here for you. Like in both cases, we get the same value 1. Like if we put I1 for 0 to pi by 2 for sine term, right? We know its integration is minus of cos x. So minus of cos x from 0 to pi by 2. And when we substitute the limit here, so what we get? Cos pi by 2 will be 0, cos 0, 1. So overall we get 1, right? So what here actually to noted here is what we get I0 value is pi by 2 and the I1 value is 1. Now proceed to our reduction. So let's write for sin x. You can also write it for cos x as well. No changes, but let's move to the sin x. So our in given is sin to the power n x dx from 0 to pi by 2, right? Is this given or not? Right. Now, the things is we have to notice here is we are going to use actually by parts, right? So first we have to write 0 to pi by 2. Just write sin x and sin to the power n minus 1. So we can write it into this form and then apply the by part because both functions are trigonometric. So you can take any function as u and any function as v. But the things is you have to take u जिसकी integration हमें पता नहीं हो. So like power n minus 1, we don't have like exact integration, but we know the exact integration of sin x. So just try to substitute u in u sin to the power n minus 1x and bh this. So when we integrate this function, so what we get? Sin to the power n minus 1x. And the integration of sin x is something like, you have to notice here one more thing. Let me write here one more thing that you have to notice is, which is, where is you, the for cos nx, you can also do it for cos nx. This will be same, right? So don't try to worry much about this. Sin n minus 1x and the integration of sin x is minus cos x. We are integrating this from 0 to pi by 2 minus 0 to pi by 2. We have to differentiate this term. So n minus 1 sin to the power n minus 2x and the differentiation will be like cos x as well, then minus cos x. And okay, so when we substitute here, what we get actually, let me go through it. When we substitute the pi by 2 here, the cos will be 0. And when we substitute the x here, so this whole term will be 0. Right? Are you getting me or not? This whole term is 0. And this minus got positive. So what we get? We get n minus 1 integration from 0 to pi by 2 sine to the power n minus 2x. And then we convert this cos square x term, we can write it into 1 minus sine square x. So let me write here 1 minus sine square x dx. So it's something look like n minus 1 from 0 to pi by 2 sine to the power n minus 2x. And then we get here, what we get here when you multiply sine to the power nx dx. Right? So there is our in. So in is equal to n minus 1 and 0 to pi by 2 sine to the power n minus 2x. So this whole term we can write it as in minus 2. Sorry, in minus 2, right? Okay. And then here we can write it as in because our in is nothing but integration of sine to the power nx dx. So when we solve this, what we get? In n minus 1, in minus 2 minus n minus 1 into in. So what we get here? We get in and 1 plus n minus 1 is equal to n minus 1 in minus 2. So we get in is equal to n minus 1 by n in minus 2. This is our final reduction formula look like. Right? I hope you'll all understand this. So you can do this same thing. अगर steps की बात करें तो मैंने क्या करी, मैंने जो sin to the power nx को दो पार्ट में break करा and then I applied the by parts here. And when during application of by parts here, I just do one more thing like जो यहाँ पे cos square x, जो यहाँ पे cos x into cos x था, उसको 1 minus sin x square लिख दिया and then automatically it get to, right? You can do it for cos to the power nx as well. So let's try it at home. Where do you want? Now, let me show you some example on this, how to apply this. Okay. So our question number 1 will something look like 0 to pi by 2 sine to the power 4x dx. We have to integrate it from 0 to pi by 2 sine to the power 4x. Okay. So here the n value is 4 because our in something look like sine to the power nx, right? So here n value is 4. So I4 is equal to what, when we apply in this formula, it will be like 3 by 4 I2, right? Then we have to find the I2 also. So when we find the I2 here, when we put the n is equal to 2 here, so we'll get 1 by 2 I0, right? And we know the I0 value is nothing but pi by 2. So here we get the I2 value is 1 by 2 into pi by 2, which is something like pi by 4. And when we substitute in equation 1, let it as equation 1. So when we substitute in equation 1, we get the I4 as 3 by 4 into pi by 4. So we'll get the answer 3 by 16. It is like easy, na? How to solve it in an easy way. Like just apply the reduction formula. First, our n value is 4. I applied for n value 4 and then we get I2 term. So again, I apply the same reduction formula for n is equal to 2. Let me write here. Applying the same reduction formula for n is equal to 2. right? Applying the same reduction formula for n is equal to 2. I hope you'll all understand this, what I'm trying to say. Let's move on to take another example and do the same thing. Just remember our reduction formula will something look like this. Just remember this form. Everything is sorted, right? Now, let us take some cost example, right? Second question, something look like 0 to pi by 2. We have to integrate the cos square x. Actually, when you derive the cos to the power nx reduction formula, it's also same. It also comes same as sin to the power nx. Okay. So let me take some for sine term, sine with the big power, right? Then we move to the cos x. So when I take the another example of sine to the power 10x dx, like here n value is 10, right? So what is a simple trick here? Like doing the same thing, but the power is, since power is even, so first multiply here by pi by 2 and then write the power and then subtract it from like n minus 1 we do. So do it here 9 and then try to reduce the minus 2, minus 2, minus 2, like minus 2, minus 2 and multiply it here. So it will be like 7, 7 minus 2, 5, 5 minus 2, 3, 3 minus 2, 1, 10 minus 5, 10 minus 2, 8, 8 minus 2, 6, 6 minus 2, 4 and 4 minus 2, 2. This is our result, right? When we solve this, it will be like 5, 2 and mm, it will be like 2 or 2, 3. So it will be like simple when we solve this, we get to the final result as with something look like this, the pi by 2 and what's here left? Here left 3 into 7 into 3 into 1 divided 2 into 8 into 2 into 4 into 2. So it will be like 61, right? Divided by 63 actually. And when we multiply this, what we get? We get 512. It now, right? So this is our answer. Now let's move on to the next example. Actually, next for odd power, let on see. Like if we get the value sine 7x dx, so there is the odd, right? So what we have to do for odd, multiplied by 1 and just do the same thing, 7, 6 and subtracted 2, 2. So 4, 2, 1, 5, 3, 1, whatever. Okay. And when we solve this, what we get? 16 by 35, right? This is our final answer. In one line answer, right? Now we move to the another formula, which is known as Wallis formula. This is actually important. We're doing the same thing, just written in proper form here. This is actually known as Wallis formula. Okay. So what it shows is, this is actually important. I m n is equal to 0 to pi by 2 sine to the power mx dot cos to the power nx dx, where m and n belongs to whole number, right? So the integration of sine to the power mx cos to the power nx dx from 0 to pi by 2 is equal to, let me write here, like First add the whole power and then subtract it, minus 1 and right. Oh, let me, I do some mistake here. Huh. Subtract 1 and then start subtracting 2 from the east term, right? Like m minus 3, m minus 5 till we get 1, and the same thing we done with the n minus 1, n minus 3 till we get the 1, right? And when both m and n integer are even, m and n integer are even, so multiply it here by pi by 2. And again, same thing we have to repeat here, m plus n minus 2, m plus n minus 4 till we get the value 1. Now, the second thing we have to write is same thing, m plus n, m minus 1, m minus 3, n minus 1, n minus 3, m plus n minus 2, m plus n minus 4 into 1. When n and m or n is odd integer. Let me write here. If there is n and there is odd, when both integer must be even, then we multiply it by pi by 2. And when m, either m or n, one is odd or both is odd, then multiply it here by 1 is odd integer. I hope you'll all understand this, what I'm trying to say. Like if the both m and n, like something sine 4x cos square x, like both m and n integer is even, right? Then we multiply it here by pi by 2, something, and multiply here by pi by 2. But like there is sine square x and cos cube x, and we are doing from 0 to pi by 2. So what we are gonna here do, like one term is even and one term is odd. So either m or n, one is odd now. So we have to multiply it here by 1. If the both is odd, then also we multiply it here by 1. Pi by 2 is multiplied if both m and n should be even. Then we multiply by pi by 2. Otherwise, we multiply it by 1. Now let me explain you again the Wallis formula. This is actually known as Wallis formula. So what it explains, if we are integrating, like हमने इससे पहले रिडक्शन फॉर्मूला में क्या देखा, like sin and cos will be integrating step by step from 0 to pi by 2, right? But what if sin and cos are written in a combination form or in product form? So what we just do, we are using the Wallis formula, which इसकी proof आगे class में maybe देखने को मिले, or maybe we get it from reduction formula as well, like the reduction formula of sin to the power nx and cos to the power nx. So you can go through it. Now, the things is what we have to do here. So first we have to add the both power, whatever written here, like we have to add the both power and then start subtracting 2 in denominator. And then in numerator, what we have to take? We have to take the first power and the second power independently. Like if we go through the reduction formula, what we get? N minus 1 by n in minus 2. Right? This is our thing. So whatever is in the power, subtract it, subtract minus 1 from it, and then start subtracting 2 because n minus 2 gonna happen now. So like minus 2 minus 5 till we get 1 or 2 whatever, and then same thing repeat it for n. And the case is multiplied by pi by 2. Why we are multiplying the pi by 2 if the term is, both terms are even, both powers are even, because we know the I0 value is pi by 2 and 0 is an odd whole number, even whole number. And for I1, it will be like 1, where 1 is the odd number, right? So we are repeating here same. If our both power is even, so we multiply here by pi by 2. If our one power is just one power or both power is odd, so we multiply it here by 1. I hope you'll all understand this. So let's try to take some example and try to understand what is the thing. So let's try to take here an example of cos cube x. Let's try to take an example of example with something look like cos to the power 4x sine square x dx from 0 to pi by 2. So what we have to do, we have to just first add the power, which is equal to 6, and then take the independent power, the 4, so subtract it from 1, and then subtract it 2 here, and then 1. And then start subtracting 2 from here, so it will be like 4 to 1. And since the power is, both power is even, so we multiply it here by pi by 2. So what we get here, like, it would get cancelled pi by 32. I hope you'll all understand this. Let us take the example of the automobile as well. So if we are integrating from 0 to pi by 2 sine x dot cos square x dx. So what here? There is the power, one power is odd and one power is even. So we just multiply it by 1. And whatever we write here. So first add the power, it will be 3, and take the independence, it will be 1. It will be 1, and then subtract it minus 2 with you 2 here, so it will be get 1. So we'll get 1 by, right? I hope you'll all understand this. So that's all for today's lecture. And today we are gonna learn some new things, some new properties, some new cases, whatever left in this chapter. Okay, so thank you. Thank you very much. Try to revise these all things, whatever we learned today. These things are highly important and mostly asked in JEE Advanced as well, not in JEE Mains, JEE Advanced as well. It is important. Those property that we learned today. The reduction formula is important, and by reduction formula we get the Wallis. So these two things are the important for today's lecture. So try to revise it and do some practice. So that will be better. Okay, thank you.